Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we are going to talk about complex numbers. And to be more specific, we're going to talk about adding, subtracting, and multiplying complex numbers. And as you will find out in this lesson, doing those three operations with complex numbers is basically like doing those operations with binomials. It's just a little twist to it when it comes to multiplication. So with that being said, let me tell you what a complex number is. A complex number is a number in the form a plus bi, where a and b are real numbers and I is the square root of -1. A is called the real term and bi is called the imaginary term. Now what I want to do next is I want to give you some examples of complex numbers. 4 plus 9i is a complex number. 11 minus 7i, it's a complex number. 3/7 plus 1/4 I is another complex number. 8 minus I times the square root of 5. Now let's look at -11i. It is a complex number because it is actually 0 minus 11i. And 13 can actually be a complex number because 13 can be written as 13 plus 0i. So as you can see here, all the numbers, all the real numbers you've been studying up to this point all fall under the complex number umbrella. Now, what I'm about to say next is very important. When performing operations with complex numbers, the solutions must be in the form a plus bi. That means when you write your answer or your solution, the real term is written first, then the imaginary term. So first, adding and subtracting complex numbers. When adding and subtracting complex numbers, just combine like terms. That's all it is. Combine like terms. So let's look at some examples. We got 4 plus 7i minus 8 plus 3i. Well, 4 and 8 are like terms, so this is 4 minus 8 plus 7i and 3i are like terms, so this is 7i minus 3i. Okay? Remember, the minus sign is in the middle. So now all you gotta do is 4 minus 8 is -4 plus 7i minus 3i is 4i. So your solution is -4 plus 4i. That's all it is. Just combine your like terms. On number 2, we got one pair of like terms. 2 plus 3 is 5. And then we have the other pair, 10i minus 7i is 3i. Therefore, the final solution is 5 plus 3i. Next, we got negative 5 and 8. That's one pair of like terms, so negative 5 plus 8 is 3. And we got I plus 9i, which is 10i. Therefore, the solution is 3 plus 10i. So as you can see, when you're adding or subtracting complex numbers, just combine your like terms. That's it. So now, multiplying complex numbers, what do you do? Well, you could apply the distributive property. If you're multiplying a complex number by a real number or an imaginary number, you apply the FOIL method if you're multiplying two complex numbers. And yes, you can also use the box method to multiply complex numbers. And that's for the two cases I have just described. So let's look at some examples. We have 7 times 5 minus 2i. So we're going to apply the distributive property. 7 times 5 is 35. And 7 times negative 2i is negative 14i. Therefore, the solution is 35 minus 14i. All right, next we got 4i times 7 plus 3i. So 4i times 7 is 28i. And 4i times 3i is positive 12i squared. Now, remember what I told you. When you're multiplying complex numbers, there's one little twist to it. And the twist is I squared. I squared has a value. It is negative 1. And because I squared is negative 1, what you could do is you could cross it out and change the sign here from plus to minus. 12 times I squared, or 12 times negative 1 is negative 12. So now, another point I made earlier is that when you write the solutions, you write a complex number with the real term first. Therefore, negative 12 is written first plus 28i. Therefore, the solution is negative 12 plus 28i. All right, number 6, we have two complex numbers. So we're going to apply the FOIL method. The first terms are 2 times 3, or should I say 4 times 3, which is 12. Next, we have 4 times 2i, which is 8i. We got negative 5i times 3, which is negative 15i. And negative 5i times 2i is negative 10i squared. Okay. Now keep in mind that I squared has a value. I squared is negative 1. So therefore, what you can do is you cross out the I squared and then you change the sign here. So now we're going to combine our like terms. First, we're going to do 12 plus 10 because remember, we want to write the real term first. So 12 plus 10 is 22. And 8i minus 15i is negative 7i. Therefore, the solution is 22 minus 7i. So as you can see, when you're adding, subtracting, and multiplying complex numbers, it's just like doing those same three operations with binomials. Again, the only twist to it is I squared equals negative 1. I hope that you have a wonderful and blessed day.